Hi everyone, welcome to week 4. This week we'll cover 5 items. First, understanding lexical analysis. Then, explain pattern recognition. Third, information extraction. Fourth, explain natural language processing. And finally, we'll examine machine learning. Thank you so much. So we're in week 4 of our class, and we're focusing on text analytics. Again, here are the learning objectives: understanding lexical analysis, pattern recognition, information extraction, natural language processing, and machine learning. So here's one application of text analysis, and it's in medical research. It's not so intuitive to the layperson, but in medical research, one of the goals is to look at causal links between symptoms or diseases and drugs or chemicals. Here's a real example, looking at the causal relationship between migraines and the presence of certain biochemical levels in the body. So basically, there's an automated kind of text analysis set of products and processes, if you will, that look at unstructured data that resides in medical research papers, medical news, journals, etc. So imagine, if you will, being able to have a machine that's able to look at all the text in all of these different sources of information, and looking at the words themselves, being able to compile a representative group of journals or related topics that show potential relations between migraines and certain biochemical levels in the body. It'll make sense here in just a minute. So here's a set of associations that were derived from text analysis. The word stress was searched for, and it turns out that stress is associated with migraines. In other words, when we looked at journals, medical news, and other sources, the words stress and migraines tend to show an association. There's a relationship between the level of stress and the occurrence of migraines. Secondly, it's in those same journals, it turns out that stress could lead to a loss of magnesium, which is one of those chemicals that are in the body. Then it turns out that calcium channel blockers prevent some migraines. So then, getting back to magnesium, it turns out as a natural calcium channel blocker. Then it looks like cortical depression is implicated in some migraines. So first stress, now cortical depression. High levels of magnesium inhibit this as well. So migraine patients have high platelet aggregability, and it turns out again that magnesium can suppress this occurrence, platelet aggregability. So through a series of associations, first stress and migraines, the fact that calcium channel blockers prevent migraines, magnesium is a channel blocker, so that says that magnesium is tied to reducing stress and therefore migraines. Then it turns out that that cortical depression is also implicated in some migraines. Therefore, the association with magnesium to deal with platelet aggregability, which is associated with migraines, is one of the analyses that has come to fruition. Let's go into the area of text analysis called text mining. So the idea of text mining is to discover new uses, for example, of current drugs through a similar set of associations, some more clear than others, but by going through volumes of text that's in journals to see if there's new uses for existing drugs, for example. Text mining has several key challenges, and namely, it all has to do with the fact that you're looking at data from various sources in different formats, with the origins of that data having different contexts and applications, if you will. And so it's not the same as data mining, where you have a structured database and very set kind of query language, and the data records themselves, the rows of data, are uniform in their format and content. So the four problems that they're bringing to the forefront is a lot of different associations or dimensions to the data. The records are unstructured and have different content in them. There's also potential relationships that are not that clearly understood or apparent. And then there's a context of the data that may be diverse and therefore obscure or make the final result less clear. So several forces have resulted in the emergence of text data. We've talked about it in a previous session. There's been tremendous advances in natural language processing, that you're going to see. Computational linguistics. Also, hardware is much cheaper than it used to be. And, with Moore's law, the processing power is accelerating. And storage costs are becoming cheaper. Here are some examples of some text mining. One is decision support in CRM, and so in this case they're looking at kind of the complaints that customers bring in. What are those complaints? Across a variety of sources. Also, you may use it in terms of what kind of offers you make for customers on the line. Knowledge management would be, finding people out there, and that's looking at a variety of data sources, public records, credit reports, various online entities that have people, information about people based on some kind of identifying information. You'll notice on the web, there are a variety of people finder applications that go out and interrogate all these different data sources and compile a package that can be used for, basically understanding an employee, their background, their education, all those kinds of things. And then personalization, in other words, in e-commerce. An example of that is in Amazon. When you make a purchase or look online, you'll see that they make a lot of offers or tell you similar products or sources that would fulfill your needs based on your history of purchases and or just inquiry online. But all that's personalization, so you're understood as an individual. Statistical analysis, again, is kind of the underpinning for all of this analysis. And we would use statistics and then look at unstructured text for statistical analysis. So here are the different aspects of that. One is, how often is a term used? How many documents is that term used in? When we talked about associations in the medical research discovery, it's looking at various terms and how closely they're placed together in a journal or medical news report, and then how long are the documents that they're querying. This looks at how words are used, and so the lexical and syntactical processing is looking at terms and assigning tokens to those terms, And then when we talk about normalizing words, there's various forms, whether it's the text, future text, present text, the constructs of language. What part of speech? Is it a noun? Is it a verb? Is it a sentence? Is it part of a sentence? Is it what, just how it's used? And then the semantic processing puts all that together and says, what is it that we're examining, and give me a full data record, if you will, that can include the name, companies that they've been associated with, and locations. Semantic processing is part of that whole online personnel, if you will, search mechanism we just talked about. Okay, so here's something to talk about what pattern recognition is, or what's the process. At its lowest level is just acquiring data and sensing physical variables, looking at what are the issues associated with the data, associated with the entities represented in the data. Then pre-processing, before we get to the patterns themselves, getting rid of superfluous data, things that aren't relevant, things that are not useful. It's looking at patterns of interest from all the data. Then it's looking at feature extraction. So it's taking all of this amount of data and it's trying to present it in a new way. And then using classification of the data to learn about patterns that are observed in the totality of the data. And then post-processing says that once I've recognized the patterns, I've identified the key entities in those things, I've learned that from the data, then I evaluate just how solidly I can believe what I'm getting out of this effort. So it's looking at patterns and evaluating the effectiveness of the patterns and the entities derived from it. Extraction is a subfield of text mining. It looks at taking unstructured data and moving it into a structured world. Or another way of looking at it is taking an unstructured document and filling in values in a spreadsheet. For example, a spreadsheet is a structured framework for data. Or taking unstructured information and putting it into a database, which is really important. So when they talk about extraction, it's taken from unstructured to structured. Again, we've talked a little bit about text processing. Again, there's some statistical analysis. There's some language or context analysis, right, to it. So let's look at some examples. One is decision support in a bank call center. So most banking call centers, the information or the customer information file is on a mainframe, which may or may not be a relational database. It may have some web-based information, but the call record is looking at all the records associated with a customer and making a decision about where that person should be placed, or who's best qualified or has the best skills to deal with that customer. Let's say they're angry, who's very good at that, or maybe has some past history and familiarization with that customer. And then also to create a user-friendly interface and visualizing everything we know about the customer. So I mentioned customer information file. Those are typically on mainframes, and what you see there are just free text words associated with the client that may be on the phone, and look at the words themselves and see if there's anything important. So it says he hates his statement format and wishes that we could show a daily balance to help him know when he falls below the required balance on the account. And also shows the length of time the person has been a client, where they're from, etc. So here's what's called sentiment analysis. It's a totally different problem domain. It's talking about movies, right? And it's plotting what people are saying about a movie and what kind of sentiment they take away from it. So it kind of tells you kind of the impact a movie has on its viewers based on, let's say, Twitter responses. Another way of depicting text analysis is through the use of charts and graphs. This is Cognos is a tool basically that is very good at visualizing data and putting the various dimensions to it. Here it's using basically bar charts to depict revenue and various other things. So it's a tool that just requires data to be able to do these things. Another is network maps, and this is thinkmap.com. And again, this is just another way of visually depicting data that was obtained through text analysis. Here's another network map from lexiquest.com. It's similar to the one before, but slightly different, display. This is something called landscapes. So as you might imagine, it's focused on geography and various attributes of or layers, if you will, of the geography. Similar to like what you see with Google Maps, where you're able to put roads and other layers on the same geography. Look at it as a like the more natural kind of bas relief or a single dimensional display. Another visualization tool. And so we've covered a lot in a very short amount of time. Text analysis has a lot of different tools. And in the future, the tools will only get better at visualization and applicability. Let's talk a little bit about natural language processing. And as the words imply, it allows the computer to understand human speech as it's spoken. There's a package called Nuance that, for example, has been used in interactive voice responses in the past. When you call a call center, instead of pushing a number, you basically say in natural language what it is that you want, and it walks you through and actually routes your call. But it's actually a very effective tool today, and is even getting more and more effective. Siri on the iPhone is an example of a natural language processing program. Machine learning, here's kind of a comic about that. And it's basically saying the machine is able to do things that are not previously programmed. It learns and it goes in new directions. So take a look at the comic. It's pretty funny. So the question is, what is machine learning? What machine learning is the ability of computers to learn without being explicitly programmed. So in the past, computers only operated based on their previous programming. What's happening today, based on or due to the extreme increase in processing speed and power and the availability of data storage and access to a diverse set of data across many formats and locations, is the ability of computers to be able to move in directions or make decisions or take next steps that were not previously programmed, in some ways programming themselves. Examples of this are Microsoft's offering called Azure, IBM Watson. in IBM Watson's case, you use natural language to ask questions. It interprets that on the front end and then is able to go and do big data analysis and various other things in the background in a very, very fast time, come back with either further questions or the results of the question that you asked originally. So that the future is now, and the capabilities of machine learning are increasing every single day. So that concludes our session, and I'm looking forward to our next visit.